session 4 of Unit 6. This session will introduce you to the various hazards associated with radiation to all spheres of human life. By the end of this session, you should be able to explain ionization radiation and its dangers. You should be able to explain the hazards associated with the application of radioactivity. Let us look at ionization radiations and the dangers associated. Ionization radiations are said to be tiny particles of electromagnetic radiations. They have high energy, and as a result, they are able to extract electrons from atoms. Now, when this happens to the atoms are said to be ionized. When we use appliances that employ radioactivity, we are at a risk of being exposed to these ionizing radiations, which we can refer to as dose. So if the dose is too high, it can lead to direct damage of the human body. Now, it is also possible that one can be exposed to one or more doses which may not have direct damage on the body, but indirectly they can have effect on the human reproductive tissues, and this can later result in cancer. Let us look at exposure to radiation. So, how are humans exposed to these radioactive radiations? Human beings are in constant contact with at least low level of radiations from natural occurring radioactive isotopes, even at our homes, in our offices, in the water we drink, even in the air we breathe. For instance, potassium 40, which is a radioactive isotope, is present in all potassium containing foods. Also, radium 222, strontium 90, and iodine 181 are also present in various kinds of foods and air around humans. Also, another way that humans can also get exposed is through cosmic rays. These cosmic rays are radiations that mostly people who travel often by air are having the chance of being exposed to, because there are fewer molecules in the atmosphere to absorb these radiations. Medical source is also one of the way people are exposed to radiations. Examples include the dental, X-ray, hip, spine, and mammograms. All these are sources through which people can also get exposed to these radioactive radiations. Also, contact with radiation during research is also one of the ways by which people can get exposed to these radioactive radiations. Let us look at radiations and health disorders. The biological effect of very large whole body dose leads to radiation sickness and early death. So, when there is so much dose in the humans, it can affect the biological system of the human being, and this can lead to death or even serious sicknesses. Also, a large organ dose leads to local cell destruction and possibly organ death. The quantity of dose that an individual is exposed to determines the effect that the radiation will have on that individual. For example, when someone is exposed to a dose greater than 100 rem, that is radiation equivalent in man. The REM stands for radiation equivalent in man. The person may suffer the symptoms of radiation sickness, like the person will be nauseous, the person will vomit, fatigue, reduction in white blood cells count. And when someone is exposed to a dose greater than 300 radiation equivalents in man, the person's all the white blood cells in the person may get destroyed, and the victim will suffer from diarrhea, hair loss, and other infections. Now, when someone is exposed to a dose of 500 rem, half of that population dies. That is when a group of people are exposed to about 500 rem of dose, half of that population will die. And so we can measure the lethal dose as 500 rem. The lethal dose 50, that is LD50, is the amount that it is needed to erase about 50% of the population. And so if a group of people are exposed to 500 rem of these radioactive radiations, about half of them will perish. So let's look at the average annual radiation received by a person in the US. The radiations are measured in millirem, that is milliradiations equivalent in man, and it has been categorized into from natural source, from medical source, and from other sources. So from natural source, you realize that from the ground, the person is expected to receive about 20 millirem dose of radiation, and from nature, the highest radiation, which is the 50, can be received from wood, concrete, and brick. Now, medically, the highest dose is received from the upper gastrointestinal X-ray, and that gives about 200 millirem of radiation. Also, from other sources, reading gives about 200 millirem of radiation, and television gives about 20. So the least source of these radiations to humans comes from air travel, which is 10 millirem. Let's look at lethal dose 50 for different life forms. So the lethal dose, as I said earlier on, is the amount needed to wipe 50% of a given population. Now, insects need 100,000 rem of radiation to wipe half a population, and bacterium needs 50,000. So we come down to humans and we need 500 rems of radiation in order to cause a death in the individual. There are two types of cells that are affected by radiations in humans. One, those that are directly involved in functioning of the organs, and they include the bone marrow, liver, or the nervous system. We can also talk about those that are associated with the reproduction, and then they give rise to these genetic effects in humans. Let us now consider how people can be exposed to a larger dose of radiation. One, by accidental exposure. Example is Japan, Chernobyl. Now, with this one, the exposure is said to be stochastic because the harm that is caused is statistically distributed over the exposed population. And also, the frequency of the tumor induction is observed to increase linearly with the dose. Another way by which people can be exposed to larger dose is by deliberate exposure. And this exposure is deterministic because the damage is caused to a certain organ or population by intention. So it's an intentional damage that is caused. Also, such damages or such radiations are considered to have threshold value, and below these values, no effects will occur. These are few self-assessment questions for you to wrap your mind around them.